Hi, my name is Marta, and in this video I will explain how to calculate the sum to infinity of a geometric progression, how to use this formula. You know already that you can calculate the sum to infinity of a geometric progression if the ratio is a fraction between -1 and 1. And then this sum can be found using this formula where a is the first term and r is the common ratio of a geometric progression. So a is the first term and r is the common ratio. Right, so let's try to use this formula. I'm not going to get into detail on how it works. That's a topic for a different video. That's how you calculate the sum to infinity, but you have to remember that it only happens if r is between 1 and -1. Let's check in here. The first term of a geometric series is 5 and the common ratio is 0.6. Okay, so the first term is 5. That means that the second term, if it's GP, geometric progression, is 5 times the common ratio, which is 0.6. 5 times 0.6 is 3. That's the second term. Plus, to get the next term, I again calculate by multiplying by the common ratio. 3 times 0.6 is 1.8. That's the third term, and so on. That's what we have. We have a geometric series. So the sum of terms of a geometric sequence. And we would like to find the sum to infinity. From this exercise, I know that the first term is 5 and the common ratio is 0.6. So I know that the sum to infinity will exist and is given by this formula. The common ratio is alright. The common ratio is between -1 and 1 because it's 0.6. So everything matches. I can use the formula. And the formula is simply that the sum to infinity, if ratio is okay, and it is a over 1 minus r. So I substitute my a is 0, what am I doing? A is 5. A is 5, that's the first term that was given. Ratio is 0.6, and that's it. That will be the sum to infinity. 5 divided by 0.4. 5 divided by 0.4 is 12 and a half. And that's it. Let's try another example. For a geometric series, the ratio is 0.5 and the sum to infinity is 16. Find the first term. Okay, so now we have the sum to infinity given. We know what it is. We know it's 16. The ratio of this geometric sequence is 0.5. The first term is something we have to find. And we know that ratio is alright. Ratio is between 1 and -1, so we can use the formula. The sum to infinity is a over 1 minus r. So I just substitute everything I have to this formula. The sum to infinity is 16, r is 0.5, and I will find the first term. So 16 is equal to a over 1 minus r. I will now solve this, and I get that a is 8. So that's the first term using the formula. And that's it. That's how we use the sum to infinity in a geometric series.